All right, welcome everyone. Welcome to the webinar featuring Dr. Tom Shao about scan to finish 3D print, 3D printed splints. So we're excited today for a really good event where we can see truly what every step that needs to be taken from the scanning process, then also to what it actually takes to design a splint, and also then what it actually means to do the printing and the curing. I'm super thrilled to have Dr. Tom Shao here from Palm Beach Pure Smiles in the Gold Coast in Australia, who is really experienced with 3D printing. He's worked with a bunch of different companies, and super psyched that he's actually working with the Ackuretta Soul now. So we're really excited to have him here because his experience really speaks for itself. Then also we have from Pacific Dental Specialties, also at the Gold Coast in Australia, Dr. Marco Morelly here, who is himself a technician and a dentist. So we really have two people here that have a lot of experience, which is wonderful because I really hope this is going to be great and educational. And yeah, without much further ado, I would like to point out to all the attendees, you have the opportunity to ask questions. At the bottom on the right-hand side of your screen, you should see a questions tab. Be sure to put your questions in there. We're going to address them in the Q&A session we have at the end. Yeah, without much talking, I would say let's hand it over to Dr. Tom Shao, Principal Dentist at Palm Beach Pure Smiles, Gold Coast, Australia, digital dentistry educator, and luckily an Ackuretta Soul user. Thank you for being here, Dr. Shao.
Hey really guys. Thanks for having me. It's always good to talk about 3D printing. It's something that I love doing in the office. And Marco and I are both based on the Gold Coast. Obviously, it's the 3D printing capital of the world. We host some live events here sometimes as well in terms of 3D printing education. And one of the most common questions and one of the biggest areas of interest shown by a lot of my attendees and fellow dentists is night guards and splints. So I guess a lot of you guys are probably familiar with some sort of 3D either CAD or CAM or printing in digital dentistry. So I guess this is what the workflow would look like. The most commonly used application might be intraoral scanning. Here in Australia, something like, I'm guessing maybe 50% of our dentists are now scanning intraorally. So from there, we capture the data as opposed to the physical impressions of the past. We now take optical scans. We can store it in the system. We then use that data. We start to design. In today's case, we're going to design a night guard or a splint, and that's done purely on the software and the computer. From there, we directly 3D print the splint without ever having a model or having any molds. The only thing that we ever kind of manufacture or be able to hold in our hands is the splint itself. And we're going to show the Ackuretta Soul printer. As you can see, there's a couple right behind me. It's the ones that I use day to day in my office. We're also going to take you through once that splint gets taken off the printer, what do we do with it? How do we clean it? How do we polish it? And what do we do to make it biocompatible for the patient? So yeah, let's have a look at the first step in the process. I mean, for that to happen, what we really need to kind of be aware of is obviously patient safety. Before we even get started, we want to understand that the workflow we're following today, and that what I follow in my office, is validated by the resin company and the hardware company, in our case, Ackuretta. So the key things to understand, every resin behaves differently. It has different properties in physical properties. It also has different printing properties. it requires more or less UV light activation to fully set the properties of the resin. Just like composite in the mouth, some composite you need to cure a little bit longer, some you can cure it a little bit less, some might self-cure. So we don't want to be making up that workflow as it goes. It's a validated workflow in the case of Ackuretta sole printers and the resins that we are using, which is in this validation is really, really important in patient safety. So if we are delivering a device to the patient, it's a medical device. In this case, it's the class 2 medical device. The device is spending a significant amount of time in the patient's mouth. We want to make sure that it's compatible. And the easiest way to do that is working with validated workflow. So it's done with the resins and the hardware company in combination. So my strongest kind of recommendation there is don't try and do your own thing. Stick with something that we know is FDA, TGA, CE approved. Cool. So the first step of the workflow in the splint case, we need to acquire the intraoral image in scanning. And this is a video that we took yesterday of me scanning one of my nurses on the Trios scanner. All jokes aside, great to have you.
Do you want me to come close to the screen again?
And my other nurses videoing and
Pardon?
You can do a variety of different angles.
So do I just stop it and then start again?
Yeah.
we see the Trios scanner here in action. We are scanning the lower arch. We want to make sure we're getting all the occlusal detail, and we want to make sure that
zoom on the here or just walk around.
We want to make sure that we are also capturing the buccal detail. In this case, we're actually designing the splint to be fitted to the upper arch, but it's not just a 3mm thick random splint. Hope for the best. We're actually building into the splint very precise occlusion. So we need the lower arch detail. Here we're scanning the upper arch, and again we need the full details. So 360 occlusal surfaces, buccal lingual. Nice to include a little bit of the palatal gingiva. Sometimes it's nice to cover the splints in that area. In that area right behind the disc of the 7, sometimes it's easier to scan if we ask the patient to close down a little bit because the muscles relax and the scanner head can reach better. So there we go. I think it took about 40-something seconds upper and 40-something seconds lower. I see that I've missed a little bit. Don't just think, oh, that'll do. It just makes our design more precise and the fitting of the client better if we don't have any gaps in the scanning. It's worth spending that extra 2.3 seconds. A really important step to take when we're taking the scan, I don't want the tip touching. Essentially, I've got a 3D printed jig. I'm placing it in the patient's mouth. In this case, I want to record about edge to edge. And Hayley here has bitten down. There is a 3mm, and I'm just checking that she's not shifting her midline.
I'm keeping that steady.
So she's got an open bite there, and the thickness of that jig is about 3mm. I then take the buccal scan on the left and the right hand side, and the intraoral scan data comes into my computer. You'll see very soon as an open bite. This is the most important step, in my opinion, in terms of splint design. If you take it in full contact, we then have to digitally open the arch upper and lower arch to create space for the splint. Here, what I'm asking the software to do is actually create a splint to fit in that open space precisely. And you will find the splint fit a lot better. I'm exporting the data onto a local hard drive. I then can use whichever software InDesign as I choose. And you'll see the 3mm anterior opening is not 6mm posterior. It's probably the reverse, if anything. But that first step was the scanning. The second step, we then use that intraoral scan data to start designing our splint. This is using ExoCAD. So it's a lab-driven software. It's very, very capable. It's infinitely adjustable. You can design different shapes of splints. You can build in articulator. You can have different thicknesses, open, close the bite. It's a very, very powerful software. And you can see on the right, it has the Ackuretta Alpha 3D built in as an integration. So here we go. We're importing the data. It's the upper arch first, lower arch next. I've exported in .ply format. Therefore, it is color. I like designing in color because why not? You can see the gum. It just looks better to me. So this is my own mouth, different scan, different set of data. This is my own STL file or PLY file. I've dropped the offset down to 0. I have allowed the undercut to be 0.17 millimeter. That creates a little bit of retention when I take the splint on and off. I've adjusted the path of insertion, in this case, to the view of the actual data to the screen. The software from here starts to block out excessive undercut. And also here, I get the chance to adjust the minimum thickness on the occlusal and the peripheral thickness. I then manually mark out, not yet. So here I go through the articulator process. Essentially, it's like mounting your articulator. There's a few different ways of doing it. Here, I'm just doing it manually. Sometimes you can mount it with 3 dots. You click on the 6, the 4, the 6, the anterior, the other 6. It'll start to line up the plane for you. Here, I'm just doing it by hand. It's kind of like the dummies version, but I can control what I'm doing here. The reason why I want to build the articulator into the bite here is then we can adjust the angles of the joints. We can then kind of see what the action of the jaw might look like. Here is a, you can open and close the bite. Some of you might ask, why don't you just take it in full closed bite and then open it digitally? It's never as accurate. When you do that, you'll tend to find a premature posterior contact. And some of you might find that when you get a lab-made splint, taken in full closed occlusion, you'll find that often you need to adjust that splint. When you take it in open bite in this manner, things just tend to fit a lot more predictably. So here, I'm about to start marking the outer, the outline of the splint. I'm adjusting the occlusal thickness and the peripheral thickness. It's about 3.5 millimeters on the occlusal and about 2 millimeters on the peripheral. So yeah, this is a lab-centric software. It's it requires our input step by step. There's nothing complicated about it. We can share with you the parameters for a successful splint design. It's nothing complicated about it, but it is a step-by-step software. The next software we're going to show you in a second actually has artificial intelligence built into it, and in our opinion, is a really, really good piece of software. So for now, we're designing the outline of the splint. You see it almost looks like the shape of my teeth. We can adjust the outline by changing the little dots around. And we can see where the contacts are, right? And that's probably a realistic splint that you get back from a lab. You end up with posterior premature contact. We can bring in the antagonist. We can now start to manually adjust. I'm going to add a bit more material across the front area. I find in my experience, and Marco will, I know, echo what I'm saying. If you're going to have any points of contact, if you're going to only have light contact, you're better off having it on the anterior teeth than the posterior, because having it on the posterior is very hard for the patient to kind of live with if it's a premature posterior contact. So here, I'm manually thickening the anterior section until I find some contact. Yes, there are more efficient ways or automated ways of doing so. You can adjust the occlusal thickness. Here, I'm just showing the workflow, what it looks like if I actually just manually adjust it. And yeah, look, it doesn't look smooth. It's not ready for finish, but I'm actually just adding material. I'm just laying down more and more splint until I'm finding contact across the arch. It's good to see that there's a few people using ExoCAD. Okay, so I'm cutting the intersection using my articulator data. I'm cutting out the premature contact or the heavy contact. I don't like that much detail on the occlusal surface because it's too limiting and too restrictive. I then smoothen it out or flatten the surfaces. Your standard lab tech will probably get this done quicker than what I'm showing here. I'm just your average Joe dummy dentist, so I'm limited in my ExoCAD abilities. If I wasn't demonstrating for the purpose of demonstrating, designing a splint in my office in ExoCAD will probably take me 3 to 5 minutes. Here I'm going through it again, cutting the intersection. This time you see it's a lot less aggressive and I'm getting closer and closer. I might just smoothen out some of the deeper cuts. So my goal here is to design a splint that I mean, you can never be 100% sure, but I'm pretty close to 100% sure that it's going to fit in my patient's mouth without needing me to fiddle with it. So if I spend an additional minute here, or even if I spend an additional 5 minutes here, and I'm confident that the patient can take the splint on without bothering me again, then I'm happy. After that, I'm done. So that's the splint. That's what it looks like. I'm not printing a model. I am not worried about the fit whatsoever. From there on, I'm happy to print that splint, hand it straight over to my patient. Obviously, we need to finish it. Yes, there are some integrations on the right-hand side. As you saw, you could drag it straight into the alpha, or you can show the file and we probably don't need to show the alpha step here. We'll skip straight over to the next video, which is a Medit Link app. So the good thing about Medit Link, it's a free software. They are obviously trying to get some market participation in their brand. This software is as good as, if not better than, some software that costs tens of thousands of dollars. So you hear I've got 10 gigabyte online storage that costs $1.40 a month. If you have less than 1 gigabyte, it's free. So essentially it's $1.40 a month for 10 gigs of online storage. I'm using this Medit Link app with the Splint software using my Trios data. I am not a Medit user. So I've exported the same data and I'm about to drag it into the Medit case files. So I'm creating a patient in Medit Link using exported PLY data from my Trios. So here are all of my patients. I'm adding a new one. I did this demo for DPR not too long ago, and this is when the app first got introduced. So we are importing the raw data in PLY. Notice in ExoCAD, and it'll be the same thing in Medit, I'm not trimming the data whatsoever. I'm not manipulating the data. I'm not putting a base on the model. I'm not even thinking about printing the model. All I'm printing is the splint itself. So that's the only thing that I'm printing. It doesn't go on a model. It doesn't belong on a model. I stick it straight in the mouth. So it's an upper maxilla. This case, I'm going to go auto creation on AI. Without having done anything to the data, I don't know how many clicks of the mouse that was, three. It takes a little bit of time. And this demo, I used my home laptop, right? It's just my standard laptop on my desktop at work, which I do the CAD CAM work on. This is probably a quicker process. Call it 10, 15 seconds there. Let's see what Medit proposes as the AI software. I ran a hands-on course on the weekend, and I know that process took about 5 seconds on my desktop. So there it is. That's the raw data. Didn't mark anything. I didn't position anything. It's designed the splint. In my opinion, I thought that was too good to be true. Surely can't fit. It did, and it fit perfectly. If you have the retention dialed up to 0.5, and that's not 0.5 millimeter, I don't believe. That's just 0.5 of an arbitrary unit of retention. The current version app allows you to dial that up all the way to, I believe, 1.0. But 0.5, I find, is the sweet spot. If you print it accurately, you can print this using the Ackuretta Soul printer in a Keystone Soft 100 times, and I could almost guarantee you to fit 100 times perfectly. It's very, very predictable. And again, I'm not printing models. I'm not doing any sort of trial fitting. That splint there is ready to go into the printer. And again, the good thing here is we've got Alpha 3D integration. We click on one button. It is going to drag every single file associated with this patient file into Alpha 3D, including the raw data. It'll place everything within the build platforms of what I'm choosing to print on. In this case, the Soul, you'll see it opening multiple files. I'm actually going to use the medium build plate, and I'm going to delete all of the other things that I don't need and only have the splint. So I start generating the supports, and I place the splint on the medium build plate. That's the splint after I finish printing it, and this is what it looks like when it fits in my mouth. I've actually got it with me in my hand. For a one-click splint, there's nothing complicated about the design. It prints perfectly and it fits beautifully. My patients love it. I constantly get patients telling me that it's the best splint they've ever had. It's a little bit soft. It's not rock hard, but it's considered a hard splint. It's very, very comfortable in the mouth. It's one application that I use day in, day out in my office, and it's very, very predictable. That Medit software with a one-click AI function is wonderful. So, okay, couple of steps that we didn't show in that video is what do we do once it comes off the printer. So, okay, we're going to talk about what the sole can do. So we've mounted it in the sole. We've sliced the software in Alpha 3D. So the splint came into the Alpha 3D software, as we saw in the end of that Medit video. We created supports. We send it to one of the printers. The sole will then turn liquid resin, as you see it out of the bottle, into a physical object. So that's a 3D printer. The good thing about sole, I mean, in my hand, in my office, the biggest thing I want is predictability. Of course, I want accuracy as well, but I just want the predictable result of it performing exactly what I think it will do. Like I said, I've designed the splint. Quite often, I then handball the job over to one of my nurses to say, please print this and give it to patient whoever. And my job is done from there after I click that one button on Medit. What I then want is to know that every time this process happens, it's predictable. In my daily workflow, I'm using the sole for this. As you say, it's plug and play. I've never once calibrated any of my Ackuretta printers. I've been told it's possible. I've not needed to. I've owned previous printers previously, and yeah, they require calibration from time to time. So I do know how to do it. I've just never needed to. It prints fine without. Therefore, I have no reason to. So it's a monochrome LCD printer. It's in my hands. I find it to be among the fastest resin printers I've seen. It's got the extra powerful LEDs and the monochrome LCD technology, which makes it print quicker than some of the competitors. So look, it's a great all-round package. I find it predictable. Let's see what happens when the splint comes out of the printer. What's our next video here? So this is me trying to film something and do something at the same time. I've got the medium build plate. If I can fit it on the medium build plate, which a single arch intraoral appliance can fit, if I can fit it on that plate, I'm using it. The smaller plate makes things print faster. There's less forces of moving the print platform in and out of the resin, is creating less peeling forces on the plastic underneath in the vat. So essentially, long story short, if it fits on the small platform, use it. It's quicker and it prints better. Straight off the printer, there is going to be some resin, a film of uncured resin on the printed device. It's always a good idea to use gloves. So I'm doing the right thing. I'm demonstrating with gloves on. I'm all about safety. imagine dipping your hand in a bucket of mud. When you take your hand out of the bucket, there's mud on your hands, right? So on that splint, there is a layer of uncured resin. If you don't get rid of it, the fit will be affected, right? So there's all the supports. It's stuck to the beautiful build plate, and the splint is made. We then get it into a washer. So I thought someone would have trimmed my beautiful videography here. We're going to wash it. So we stick that entire build plate into the washer. Let's have a look at that. So that's the cleaning. We've got the build plate. We can dunk the whole thing straight in. We turn it on. It'll start washing it. It's a dual tank washer, so you can get rid of the bulk of the resin in the first one and reserve the second tank for so the alcohol is always nearly perfectly clean. We'll let it wash for a couple of minutes, and then we take it off the build platform after it's washed, and then we stick it in the curing. So this, in my opinion, is the most important part of the whole process. Well, I mean, every part's important, but this is what makes sure it is biocompatible in the patient's mouth. What you see in that little container is actually glycerin. I like glycerin. It makes curing more complete. The object that you're curing feels better once you use glycerin off the curing. So here's the validator workflow. I scroll through the menu. Keystone, key splint soft is a 10-minute job in the curie. If you flick through the websites, you'll see what is validated and what isn't validated on the key splint software on the website. And you'll see curie is one of the fastest curing lights on the market. Some might take 60 minutes. So 10-minute curing in the curie completes the workflow. So after 10 minutes, my splint is ready to be inserted in the patient's mouth. Of course, we need to remove the supports. We cut off the supports with some shears or scissors. Sometimes you can even break it off with your fingers. My nurse is doing this and I'm filming. You're essentially knocking off the 0.8 millimeter support contact point. And as much as people think this is going to ruin my occlusion, it just doesn't, right? It just doesn't change your occlusion all that much. Whatever is designed to fit will still fit after you do this. You're not actually hacking away the splint, you're just breaking down, you're just taking off that little contact point where the support is contacting the splint. You see how little force she's using. We're just applying a bit of coating so it looks nice when you insert it. So this is a trick by a lab tech. He said, stick some baby oil on it. That was actually the first time I did stick the baby oil on the splint. Normally I issue it just with knocking off the supports, and then we have those little what do you call those little things with a little fur on it, and we just give it a little light polish. So that essentially is the workflow of us designing from scan to design to printing the night splint. In my office, it's probably the most widely used application in 3D printing. Perhaps I print more models than I do splints, but I'm constantly finding applications and uses for splint, whether it's TMD or if I'm trying to protect my patient's ceramic work or composite work. I even, if you print full coverage on the buckle, it's perfectly okay to be used at night for an ortho retainer as well as a splint. In fact, I've been wearing one of these, not this one. This is just a demo, but I've got one of these at home I've been wearing, and it's very, very comfortable. The material, I don't know if you can see on camera, if you kind of flex it, it does flex a little bit, but it still feels like a hard splint in the mouth. Happy with that, Julie? Do you want to hear what Marco's got to say?
Yeah, thank you so much. I think that was a really good in-depth explanation, especially when it comes to the design part. And it's super interesting to highlight also MeditLink, right? Because they just came out with that new software features. So thank you so much for taking that time to really go in depth and explain every step the way you do it, because I know a lot of people have questions about how to produce splints. And in the chat we're seeing right now, like Dr. DeLeon from the US, I know he's been having a lot of questions, so it's great. Thanks for joining, and for everyone else as well. Be sure, guys, attendees, to put your questions in the questions tab. We're soon going to start opening the Q&A session, so please feel free to add it in the questions tab. Okay, we're coming now to Dr. Marco Morelly from Pacific Dental Specialties, sorry. And actually, I think it's super interesting that you are a dentist and a technician by trade. And now you're the national manager, sales manager for Pacific Dental. So yeah, super excited to have you here as well. I think people are going to be really interested to hear what Pacific Dental does and what you guys recommend, especially newcomers to 3D printing, how to start out. So let's see.
Thanks, Julia. Hello, everyone. Hopefully you guys can hear me properly. Is that good, Julia? Can you hear me properly?
Yeah, your audio is great. I think your audio is great.
Cool. Well, hello, everyone. Look, my name is Marco Morelli. I'm working for Pacific Dental Specialties for nearly 3 years now. As Julia said before, background, so I'm a dentist from Venezuela, South America. Also a dental technician, and now working for Pacific as a national sales manager. I've been working in dental lab for quite a long time in the digital side as well. So I don't think I'll be able of. I would never go back to the way I used to work before. I think the presentation from Tom, it was really good, because basically it's pretty much the starting point for anyone that is wants to pretty much get into digital, intraoral scanning and 3D printing. And this is a really, really good example. Trios scanner, as he mentioned before, simple to use. And also the designing software as well. Extracat, as he demonstrated before, that was a lab version. A little bit more complicated that would be but that the Medit will be, but still simple to use. Also with the Medit scanner, you have the option of having different apps and little bits and pieces within the actual MeditLink platform. Very, very helpful. Just a really good starting point as well before committing to designing softwares. Well, as far as Pacific Dental Specialties, we are in the Gold Coast in Australia. We provide dental equipment for both the clinical side and the labs. Okay, so for the clinical side, we do a lot of implant componentry as well. We do a lot of scanners, intraoral scanners, a lot in the lab section. We do 3D printing, milling machines, lab scanners as well. So we've been in the industry for quite a long time now. Yeah, we're sort of like really focused in digital at the moment, especially with scanning, printing, and milling.
Great. Marco, how about we tell them real quick that we do have a special Australia bundle that you guys are going to be offering that includes that medium build platform that Dr. Shao was having there. So guys, if you want to get your own system and your own setup, I recommend talking to Marco Morelly. We're going to drop the information in the chat, so that is available.
Cool. Yeah, so as you can see, guys, there's a bundle there. Feel free to reach out for any questions as well. There'll be a section here where you can ask all the questions, but if there's anything specifically, you can actually reach out to me through my email. I'm happy to respond to any questions. My contact numbers, I think Julia's are you gonna share that as well for people in Australia?
Yeah, I'm sharing it right now. Yeah.
Okay, cool. So happy to help, and yeah, with any matters of the for the printer and for everything, even a little bit of help and afterwards to how to design your own splints and everything. If you currently have a scanner in your practice, I'm happy to help with that as well.
All right, then I would say let's take it over to Q&A. We did get some questions. Marco, you've already answered quite a few of them, but I think it might be good to bring some of them up again. So we have one question from Elias who said, don't we need hard material to stabilize the grinding actions because soft material will activate muscle and cause more harm than less? So what's your view on that, Dr. Shao?
So perhaps the name of the material is a little bit misleading. It's not that soft, as echoed by a few of the doctors in here that have actually used the material. We would consider it a hard material. It's certainly, yes, I understand that's the literature. This is not your traditional soft material. So when we talk about the soft material, you're almost talking like a mouthguard material. This is nothing like it. So I believe this behaves like a hard splint. It just has some elasticity properties, and it also does thermoform a little bit. So if you place it in warm-ish water, so I never tell my patients to place it more than, say, 40, 50 degree water. It actually just softens the material a little bit more. But once you put it in the mouth, it just feels like a hard splint material.
All right. Actually, I think we can follow that up with another question here from Miguel de Leon. He's asking, do you still leave the indentations, and then do the patients feel like their bite is stuck like that? I think that.
Yeah. So what you see on ExoCAD is not what you're actually going to receive with the splint. It looks a lot more aggressive in there than in real life. None of my patients have ever felt like they are locked in like that. And one of the steps in ExoCAD is a dynamic cut intersection. So I've got the dynamic movement built into the articulator. It allows freedom of movement. So it's actually cutting away material to not lock you in.
Okay, we're going sort of backward. Yeah, sorry. Okay, go ahead.
No, I was just going to talk about the same question that, same point that Tom was talking before about the soft and the hard material. And yes, it's true what Tom is saying. Maybe the name of the material is what people get a bit confused. Although, to be honest, there's always been believed that hard material is actually better for the muscles than the soft material. But there's also studies in patients, and there's a very interesting study. I just put the link for one of their questions. When 50 patients, basically, they didn't really show too much difference between the hard and soft regarding the muscles and things like that, and the clicking noises. So it all depends, I suppose, of how soft the material would be.
Agree.
And sorry, didn't you also say, Marco, that you're working with a different material, right? Would you want to talk about that?
Well, we've got different materials in our range. Apart from Ackuretta, we also provide next-gen resins, because we do have next-gen printers, but we also have Dentona resins. So on the next-gen range, we've got ortho-rigid which is their hard material. And we also have Orthoflex. I'm pretty sure Tom has used Orthoflex in the past. They're actually quite nice, depending on what you want to do. From Dentana, we've got Dentana Clara, which is actually really good too. I suppose is with splint materials, it's more about trying and see what you really feel from your patients, or the feedback you get from your patients too. I think in the market, a lot of the materials are really good, to be honest.
Yeah, okay. Then we have a question about the scan bite. And so one of the questions was, Dr. Shao, if you're using a 3D printed gauge or now I'm going to mispronounce that name, Vu Li. I know who he is, that 3 millimeter jig he made.
It's just an STL file that that is just like a little bite ramp. We can share it with you actually. So it's just a, to be honest, I don't know the exact origin or who to credit the STL to, but it's been doing the rounds. We just print hundreds of them and we use them once and we throw them out. But when we're doing something like that, we're printing in biocompatible resin. So that resin that you saw, the little see-through yellow, is a NextDent surgical guide resin.
Okay, I see that Dr. DeLeon had a follow-up question. So if you don't articulate the night guard digitally, you won't get dynamic cut and thus would not be as good. I wonder why it's better to use Exocad versus Medit Link at this point because of how Medit gets those pinpoint occlusion and not have to worry about articulating. That's a very long question. I hope you got that.
Yeah, got that. I can see it. Yeah, look, if you don't articulate it, you won't get that dynamic cut, correct? So why would you use Exocad versus Medit? Because Medit, the pinpoint occlusion, I mean, I'm not sure how accurate the occlusion is in Medit. That will be my short answer. Yes, it does fit fine. I have tried it in my own mouth. It's nothing like trying in your own mouth and your own occlusion because you're going to be super aware of how things feel. Yes, I agree. But I have also found, I do find perhaps the Exocad occlusion to be more precise.
Okay, more questions about the measurement of the jig. What measurements is best to use on the jig? And then we had a different question. Yeah, is a jig handmade or from a specific company? I think we've already answered that. It's an STL file that we can share here. Dr. Shao, I'm sure you can share it with me and I'll make sure that it's made available. Yeah, measurements of the jig. Is there a specific?
So I have a 3, 4, 5 and a 2, patient dependent, application dependent. It's up to the doctor for what you're using. Most of the case, my nurse hands me the 3 mil jig. I stick it in and I scan it.
Okay, we have one question from Richard Haber asking about whether or not the sole can print with resins that are 50% inorganic filler, such as like for permanent materials for crowns. So the Ackuretta sole is compatible with the Bagel Zero Smart Crown Plus, the Ceremco Crown Tech, and also the Pectent Rodin Sculpture resin. Now, to be honest, I'm not entirely sure if it's more than 50% inorganic filler, but if you shoot me a message, I will be sure to reach out to you to let you know, yeah, if that is 50%, more than 50% inorganic filler.
Yeah, I have tried, I have used repeatedly on the sole with microfill hybrid crown bridge resin. So yeah, I'm with Julie. I'm actually unsure what the percentage of inorganic filler is, but yes, it's validated for the ones that we mentioned. So it's it certainly works.
Okay, I think we have covered the majority of the questions. Thanks to all of you for taking the time, especially Dr. Shao. Thank you so much for really taking your time to go through all of these steps. Again, that is very invaluable for a lot of people to see, you know, your workflow. And because you have great results with your workflow, you've said yourself, you barely have any failed prints. That's where we want to have everyone at, right? And of course, Marco Morelly, it's fantastic to have you here because yourself also so experienced with all of the equipment and the workflows. So big pleasure from my side. Did you guys have any closing words? Yeah.
Can I say one thing about the medium build plate?
Of course.
So the medium build plate, I see a few of the guys saying that they've had some difficulties using. If we look closely, the medium build plate is actually a different texture. It's a complete polished texture as opposed to the large build plate. And Julie, am I right to understand the new medium build plate soon will have a different surface?
Yes.
Which will add adhesion to the top layer.
Yeah.
In the meantime, what we have done is added a few seconds in the base layer. So Julie and I've spoken about this before. We've added somewhere between 5 and 10 seconds to the base layer, and that's the only thing that we've changed. Rather than trying to scratch up the plate, and I've got one right behind me. Rather than in previous systems where when you buy a new printer, they ship you out a bit of sandpaper. I've left it as you can see it's almost polished, right? I haven't done anything to the surface. I've just added a few seconds on that base layer. It fixes everything.
Awesome. That's a good hack. So yes, the build platforms are now being changed to hairline anodized build platforms. That makes sure that the first layer has great adhesion. Yeah, so there is a change. I think it is also available on our newsletter and our website. You can find that information. If you have any questions, everyone, feel free to reach out to me. Feel free to reach out to Tom Shao as well, who will probably lead you to me as well. So, and check out our website, right? Yeah, we will send an email with that information to you guys after the event. And if there's any follow-up questions, feel free to reach out to Marco Morelly as well. Yeah, I mean, all of you guys have so much expertise, so it's really fantastic to have you out in the field doing this education. It's super important for Ackuretta, and it's super important for everyone that wants to learn about 3D printing. So you guys are really pushing the boundaries. Thank you guys. Thanks for being here.
Thanks very much. That's a great deal.
Thanks so much, Julia. It is really good. So we just gotta make aware all the customers in Australia. This is US dollars, though.
Well, I was going to. So what currency is that, Marco?
Yeah. So that's US dollars at the moment.
Yeah.
Yeah. Okay. We will be giving that information out as well, and be sure that everyone is on top of that. Okay. Thank you all. Then thanks to the attendees as well, of course. And I hopefully will see you all around very soon for our next round.
Bye.
Thank you so much, Julia, for having us. Thanks,
yeah, of
Tom.
course. Bye, guys.
Thank you so much. Bye.